All right, you guys, today we are going to be talking about solving right triangles. And the good news is that solving right triangles, meaning find every single angle and every single side in a right triangle using trigonometry. You have done this whether you were in regular geometry or honors geometry probably 2 years ago. The only difference here is that we now have angles in minutes and seconds. Degrees, minutes, and seconds. So if you need to remember where those buttons are in your calculator and you forget, depends on if you have an 84 or an 89, but I would just Google where are degrees, minutes, seconds in the TI-84 calculator or whatever, and it'll come up right away with where to find those buttons if you forget. We've been using them in class, hopefully you don't forget. But I want to point out one thing about this triangle over here. Whenever you draw a right triangle, the right angle is always C. That's just standard, and that's how we're always going to set up our right triangles when we draw the picture. And then A and B doesn't matter, but what you do need to notice is that if angle C is the right angle, then the hypotenuse is side little c. And then notice that big B is the angle, and it's across from little b, which is the side. And big A is the other angle, and it is across from little a, which is the other side. So that's how I'm going to draw all my triangles. You can flip it upside down, turn it, reflect it. It doesn't matter. Just make sure that your sides are across from the angle, and you keep everything labeled appropriately, okay? So I'm going to dive right into this first one. Solve right triangle ABC. I'm going to draw a right triangle. Doesn't matter which way it goes. Remember, the right angle is C. A and B doesn't matter. But if angle A is 34 degrees and 30 minutes, you can just type that into your calculator. And angle or side C, notice how that's a little c? That tells you it's a side length. And there's no degree symbol there, duh. Okay, 12.7. So what I have to do is use trigonometry, and I'm going to use this angle. I'm going to type it into my calculator, and I'm going to solve for, first thing I'll do is I'll put a little b here. I'll solve for that one first. I can also solve for side A here, and then I'll talk about solving for angle B. So the first thing I'm going to look at is I have a hypotenuse degree, and I want to find, it doesn't matter which one you want to find first, I'll find B first because I wrote it first. So this is my adjacent side, and this is my hypotenuse. So go back to what you learned originally about SOHCAHTOA. Adjacent and hypotenuse is cosine. So my formula is going to look like this. Cosine of 34 degrees 30 minutes equals the adjacent side, which is the B, over the hypotenuse, which is 12.7. So all you're doing is typing this into the calculator, and when you do that, you're going to get a decimal, and then make sure you just multiply both sides by the 12.7 in order to get B by itself. And you're going to end up with B equals 10.466. Okay, so check that. Make sure you're actually typing this in the calculator with me. I'm also going to set up an equation for finding little a. And so notice how I have my angle here. A is opposite that, and I still have my hypotenuse. So could I do tangent here and use A and this newfound B that I just found? Yes, you could, and you would probably be safe doing that. My only caution is, what if you made a mistake finding B for some reason, and then you used it incorrectly to find another variable in the triangle? Then you would miss both questions. So I like to just use a rule of thumb. Just use the angle and the side that you're given always, just in case you screwed something up here. Okay, but if you're going to do the tangent and use A and the B that we found, you would still get the correct answer because I know for a fact this is correct. Anyways, let's move on to finding A. So that's going to be sine. Sine of 34 degrees 30 minutes equals little a over hypotenuse. And remember, I'm using sine here because this is the angle. The side opposite that is my little a. So opposite and hypotenuse uses the sine function. Again, you're just going to type that into the calculator, multiply both sides by 12.7, and you'll end up with A equals 7.193. So those are our two answers for A and B. And the only other thing we need to find is this angle right here. But keep in mind that we know that this angle plus this angle plus this one adds up to 180 degrees. So all we have to do is subtract in order to find that. So in order to find B, all I'm going to do is subtract from 180, and that's going to get me B equals, let me check my math real quick, 55 degrees, 30 minutes. Yes, I did that one in my head because it's just 30 minutes. So think about like 30 minutes and 30 minutes, that equals an entire hour. So then when I add 34 and 55 and the entire hour of 30 minutes and 30 minutes, that gives me the 90 that I was looking for. And moving on to the next question. All right, so that, you guys, is how to solve a right triangle. So again, you have done this in geometry class before. Just wanted to recap with you. Don't forget, this is how the triangle should be set up, making sure that your angle and your sides are across from each other so that they match, and therefore it doesn't matter if you start with A or B or the first angle or which trig function you use. Those are just all little tips for you. So what I encourage you to do is to try this one, pause the video, and then I'll just show you the answers. All right, guys, so here's what my problem number 2 looks like. So I drew my triangle and I put A, B, and C, make sure that C is the right angle, and I labeled the hypotenuse, which is across from the angle C, the 53.58, and I labeled whatever's across from my angle A is the 29.43. So first thing you guys can do is remember Pythagorean Theorem. You can find this number very, very quickly. Do A squared plus B squared equals C squared. This is your A squared. You're solving for B squared, and you have C squared. So that's step 1, just to knock that one out right out of the way. The second thing is, it doesn't matter if you want to find angle A or angle B first. I just thought of angle B first, so I went with it, and that would be cosine because you have your adjacent side and your hypotenuse. And then remember, your equation looks like this, and how to get the B by itself is to use the inverse cosine. So make sure you're using the little -1 button in your calculator. And that gives you this angle measure, and then you can just subtract this from 90 to get that one, which is your third angle of the triangle. If you solved for angle A first, then you have the side that is opposite that and the hypotenuse, so that would be sine, and you're using this ratio, and then again inverse sine to get the A by itself. That would have given you this degree, and then you subtract from 180 and get this for B. Again, could you have used other trig functions besides cos or sine? Could you have used tangent with this Pythagorean theorem variable that you found and this side? Yes, you could, but just beware. You might have made a mistake here, and if you use something that you made a mistake on in the rest of the problem, you might get the whole thing wrong. So I like to use the problem, or the numbers that you're given. Okay, now let's move on to a word problem. I'm going to do this one, and I will be finished there. I'm going to save number 4 to do together in class tomorrow. Okay, so I'm just going to do number 3, and then the video is over. But we have this girl, Shelly. She is standing from the base of a flagpole, angle of elevation. Oh boy. So again, you guys did this in geometry class. Just to review, angle of elevation is someone out here looking up at something, and the angle is measured from the ground up. Angle of depression is someone like on the top of a building looking down at something. And the angle of depression is measured from the horizontal line down to the angle. So that is angle of depression and angle of elevation. In this case, we have an angle of elevation, so I am going to draw Shelly. It really helps to draw an actual picture of a person, because then in your triangle, you're like, wait, where's my flagpole? Where's my person? Whatever. Okay, so Shelly is looking up at a flagpole. Don't make fun of my drawing. Okay, and her eyes are here. She's looking there. All right, the angle of elevation to the top of the flagpole is 26 degrees, 40 minutes. So that is my horizontal line, and what I'm going to put here is 26 degrees, 40 minutes. So she is looking up at the top of the flagpole. She stands, where do I put this, 120 feet? So she is 123 feet from the base of the flagpole. So here's her feet, here's the base of the flagpole. This distance here, which is the same as this distance here, I'm going to label that 123. Same thing down here. Okay, the angle of elevation to the top of the flagpole, I got that. Her eyes are 5.3 feet above the ground. That's kind of a weird thing to be measuring, but whatever. 5.3. See the rectangle down there? Okay, cool. So what we need to do, I'm going to make a note that this is only measuring that part. Find the height of the flagpole. So do you guys notice that this is the entire height of the flagpole? So whatever I find for this using SOHCAHTOA in my triangle, I'm going to have to add to 5.3 in order to get the final answer. So all I'm going to do here is, let's see, I'm looking for this, which is opposite. I have a side for adjacent, so that would be tangent in this case. So I'm going to do tan of 26 degrees 40 minutes equals opposite. I'll put an X there, or you could put an H or whatever letter you want, over adjacent, which is 123. So again, you're typing this into the calculator using your degrees and minutes buttons, and then you're just going to multiply by 123 to get X by itself. So that's going to give you X equals, let's see, 61.773. And then remember, that represents this right there. So what I have to do is add the 5.3 to it to get the entire height of the flagpole. When I do that, I get 67.073 feet tall. So just make sure, you guys, that you're always answering the question. It might seem simple and like review geometry stuff, but the way that they make these harder is to make sure that you're paying close attention, drawing an accurate diagram, and answering the question, find the height of the flagpole. A lot of people will stop here and think that they're finished and just have this 61 as their answer. And what really sucks, you guys, on the final exam and on lots of tests and ACT and SAT and all that stuff, this will of course be one of the answer choices. So you have to make sure that you're answering the question being asked. Okay, that's all for today. Thanks for watching. Bring questions to class tomorrow as always, and we're gonna do number 4 as a warm-up, okay? See you guys later. Have a good night.